Now my dear, in this video, let us discuss the case by the astronomical telescope, the refracting telescope, when the image is formed at infinity. When the final image is formed at infinity, first we will see the ray diagram, then again we will write about its working, and then magnifying power. So here my dear, let's begin with the ray diagram first. So here again I have drawn the objective lens. At this distance I will keep the object. As I told you, object no need to show, but you can show also. You can put a distance here. Here you can write AB. That is object at infinity. And my dear, here is the optic axis. This is the point O called objective. That is objective lens with the focal length FO. One of the ray coming from optical center. And the another parallel ray will come from here, like this. I can draw at the dotted line at the back like this. And here I can write the parallel beam of light. Parallel beam of light from distant object. Parallel beam of light from distant object. Now my dear, simple concept, you all know that here sir, it will be fall here, this parallel beam of light falling on the objective lens. It will be, it is going here and they are making the image here, diminished image, the real inverted and diminished image. Let the name of this image is, my dear, B dash, A dash, you all know. This image which is formed by the objective lens. And here I will keep the eyepiece. Here I will keep the eyepiece, my dear. I will make objective little more than and here I will place the objective lens. This is the eyepiece lens, my dear. And as I told you, my dear, in the eyepiece lens, here is the point where these two rays are coming and they are meeting. So what I suggested, you draw the first ray from the optical center of the eyepiece like this. The second ray you draw like this. The third ray you can draw like this. See, these are the rays which you can draw, my dear. And infinity diagram so very easy, my dear. And here, my dear, if I draw it like this, no doubt one ray will be go parallel to the principal axis like this. and it will pass through the principal focus of eyepiece here on this side, but this also I will make it first here to draw like this. So this ray will go here, this ray will go here, my dear. That is nothing but to the principal focus of eyepiece, Fe dash, I can mark it. Even this ray will go like this. Even this ray will go like this. You all can see, my dear, and this ray is also going from optical center like this. So now I will put this dot lines. Now I can make this as a dotted lines. I can make this as a dotted lines. So nice, bacha, see the diagram method of drawing the diagram. This is also made a dotted line. This is also made a dotted line. So here, my dear, I can see the image forming at infinity. Everybody can see the image is forming at infinity. So here I can write this word that here the image is at infinity. So here I will write from infinity. That is, image is from infinity. Image formed at infinity. The last one is here. What I have told you the last time in my previous video. Here you can see the distance, my dear. No doubt this is coming from infinity. So objective lens will form this image A dash B dash at the principal focus. At the principal focus. So from here to here, my dear, from here to here, it is FO. You all can see. And since the eyepiece is forming, this is your eyepiece denoted by E having focal length Fe. Since eyepiece is forming the image at infinity, so no doubt this image A dash B dash, which is nothing but the object. Now I will adjust the eyepiece here. This is what is the difference. Earlier it was within the focal length of eyepiece at distance of UE, but now, my dear, this is lie at, I will put comma and I will write Fe also. Because this point is a common point where FO and Fe both you can see, both the things you can see. That is, at this point it is FO also and Fe also, and here I can mark this distance here from here to here, my dear. You all can see this distance is Fe. Please make a note of this. This is what is the crucial, my dear, because eyepiece forming the image at infinity. So when the eyepiece will get the image at infinity, when the object is at its focus, when the eyepiece form the image at infinity, when the object is at its focus, so this object A dash B dash act as the object, so it should be at the focus of eyepiece, but this image is obtained at the focus of objective by the objective lens. So FO and Fe will be coincide, my dear, in the diagram. Please take care. Am I clear? And this I will brought at the focus of eyepiece by adjusting the eyepiece. The image को, which is act as the object for eyepiece, I brought it at Fe by adjusting the eyepiece. That all I will write in my working. So now, my dear, here you can see again here also. This is the parallel beam of light coming from distant object from infinity and falling on the objective lens, making an angle alpha, that is angle subtended by the object. Same concept you can use the angle alpha can here also by geometry of the figure, vertically opposite. Eyepiece forming an angle, or eyepiece forming, my dear, the image, the final image at infinity. So here is the angle, and that angle is beta. That is the eyepiece forming the final image at infinity with the angle beta. So I marked alpha, I marked beta, I marked FO, I marked Fe. Everything is over and image is at infinity. So now, my dear, here what is the length of tube? So here the length of tube will be FO plus Fe. Here the length of tube is FO plus FE when the image is formed at infinity, my dear. Take care. Whereas earlier it was FO plus UE. This is very important while doing the numerical. In different situations, the length of tube is different. So this is the final diagram, my dear, for the image at infinity. So now let's start once again the working. When I start writing working, my dear, you all know, you please help me for writing 4 crucial points of working. Point number 1, the parallel beam of light, the parallel, same 2 points as earlier, please look at the points. The parallel beam of light from distant object, you can see the parallel beam of light from distant object falls on objective lens, making an angle alpha, that is angle subtended, by an object. So this is the same concept, same I have written in earlier also. So try to understand, because whenever they ask working, find out what are the common things. Whether the image is at LDDV or whether the image is at infinity. What are the common things? This is common. The parallel beam of light from distant object falls on the objective lens, making an angle alpha. And that angle alpha is nothing but angle subtended by the object. So alpha story is over. Now my dear, next step, point number 2. What this objective lens will do? Sir, objective lens will form a real inverted and diminished image. What is the name of that image? A dash B dash. Where it form this image? At the principal focus of objective. So now my dear, here the objective lens forms real inverted and diminished image A dash B dash. The objective lens forms real inverted and diminished image A dash B dash. कहाँ पे बेटा? At the focal point of objective lens, that is at FO. Yes, this A dash B dash is the real inverted diminished image formed by the objective lens. कहाँ पे? At the focal point of objective lens, that is at FO. Same point. Earlier also this was happening. Now point number 3 is the change. Point number 3 is the change, my dear, from previous to now. From LDDV to infinity. And what is that point number 3, my dear? This A dash B dash is the object. This A dash B dash is the object for the eyepiece. Everybody knows. So now, my dear, if this is the object for the eyepiece, I will adjust the eyepiece. And by adjusting the eyepiece, I will bring this object A dash B dash at the focal length of eyepiece or at the focal point of eyepiece. इसको एडजस्ट करके मैं इसको ये इमेज को जो ऑब्जेक्ट है इसको मैं आईपीस के फोकल पॉइंट पे लेके आऊँगा. इसको एडजस्ट करके आईपीस को एडजस्ट करके so that the final image by eyepiece is formed at infinity. That's all. So my dear, here this image A dash B dash act as a object for eyepiece. This image A dash B dash act as an object for eyepiece. So by adjusting eyepiece, my dear, A dash B dash is brought at the focal point of eyepiece, that is at FE as shown in figure. अच्छा, क्यों इसको फोकल लेंथ ऑफ आईपीस पे लाना पड़ा? सर, if object is at focal length, the image is at infinity. If the object is at infinity, image formed at focal length. Now, if the object is at focal length, इसीलिए लाना पड़ा, so that eyepiece form the image at infinity. इसलिए I brought this A dash B dash, which is the object for eyepiece. I brought this object at focal point of eyepiece, so that eyepiece will form the final image at infinity. So here, my dear, this image A dash B dash act as the object for eyepiece. So by adjusting eyepiece, my dear, A dash B dash is brought at the focal point of eyepiece, that is at FE, as shown in the figure. Hence, eyepiece help to form a final image at infinity. Hence, eyepiece help to form a final image. Eyepiece help to form a final image at infinity, which is real, inverted, and magnified with respect to the object. So the eyepiece help to form, my dear, the eyepiece is help to form the final image at infinity, my dear, and this image which is obtained at the infinity is magnified, inverted, real with respect to the object. So which is real, inverted, and magnified. You can say it is highly magnified, because object is also at infinity. So image which is obtained at infinity, my dear, is highly magnified with respect to the object. So I hope you all understood the 4 crucial working points. So once again, my dear, first, sir, the parallel beam of light will fall on the objective lens, making an angle alpha, that is object angle, that is angle subtended by the object. This objective lens will form its real inverted diminished image A dash B dash. कहाँ पे बनाएगा this objective lens this image? Sir, at the focal point of the objective. Am I clear? Okay. Now second point, this image A dash B dash is act as the object for the eyepiece. So I will adjust the eyepiece and I will brought this A dash B dash. I will brought this A dash B dash at the focal point of eyepiece. Why at the focal point of eyepiece I have to brought this A dash B dash? So that the image by the eyepiece will be formed at infinity. Because जब object focus पे होगा तो image infinity पे होगा. So I adjusted eyepiece and I brought A dash B dash at the focal point of eyepiece. Here you can see the diagram FO and FE at the same point. Am I clear? And then eyepieces help us to form the final image at infinity, which is real, inverted, and highly magnified with respect to the object. So this is, my dear, a working process of the final image at infinity. Now let's go to the magnifying power and its answer. And then I will compare both the cases and I'll let you 2-3 more new points, which is very important, crucial for the MCQ point of view. Go for the expression for the magnifying power at infinity and definition also. So now let's start here. Magnifying power for infinity. So now, my dear, when I define this as the definition, you all know it is the ratio. Again here it is the ratio of angle subtended subtended at the eye by the final image, where the final image is forming. Simple, final image formed at infinity, to the angle subtended at the eye by the object capped at infinity. So object is at infinity because distant object. It's very simple. Earlier also the object is at infinity, but image is at LDDB. Now image as well as object. Object is at infinity and image is formed at infinity. So take care, this is a simple answer. It is a ratio of angle subtended by the final image, where the final image obtained at infinity, final image formed at infinity, to the angle subtended by the object at capped at the infinity. Okay, so now my dear, here according to the definition, so what is m infinity? So m infinity, magnifying power at infinity, is angle by image, that is beta, to the angle by the object, that is alpha. Both are at infinity. Beta by alpha, this can be written as 10 beta divided by 10 alpha. Now my dear, 10 beta, you can see in the figure, 10 beta can be written as a dash b dash upon b dash e in triangle a dash b dash e. This is triangle a dash b dash e, and 10 alpha is nothing but a dash b dash upon ob dash, that is in triangle a dash b dash o. So this answer I got it from triangle a dash b dash e. Here I have written e. I am writing here from triangle a dash b dash e, from triangle a dash b dash e, and this is from triangle a dash b dash o I obtained 10 alpha, and from triangle a dash b dash e I obtained 10 beta. Earlier also we did the same. Now my dear, here a dash b dash is cancelled. So here my dear, m at infinity will be what? This is ob dash upon b dash e. Now here ob dash, you all can see ob dash is fo, and b dash e is minus fe. It can be written as minus fo upon fe. So now my dear, I hope everybody understood that the image when formed at infinity, my dear, the magnifying power, when image formed at infinity, the magnifying power is minus fo upon fe. Where this minus sign indicates, negative sign indicates the final image is real inverted. Negative sign indicates the final image is real inverted, or you can say it is inverted. Negative sign indicates it is inverted. Here also my dear, also FO is greater and greater than FE. We all know that the focal length of objective is greater and greater than FE, my dear, or as compared to focal length of eyepiece. So now my dear, we can say thus the magnifying power thus the magnifying power is large. Since FO is greater and greater than FE, since I will write also since since FO is greater and greater than FE, thus the magnifying power obtained is large. Because FO is greater than FE, so of course magnifying power even at infinity is obtained is large. But my dear, now let us compare. So now let us compare, my dear, the magnifying power at infinity and the magnifying power at LDDB. And out of these two, which is more? No doubt the magnifying power at LDDB is more. So here some important point. Important conclusions. First, my dear, the magnifying power at LDDB is, my dear, answer is minus FO upon FE. Minus I am not writing now. It is 1 plus FE by D. And magnifying power at infinity is FO by FE. That is in I have not written minus sign because all minus sign indicates the nature of the image, which is real inverted in both the cases. The nature of image is inverted in previous case also, in this case also. I have just written there magnitude, magnification in terms of positive magnitude always. So I have written in the terms of magnitude, my dear, FO by FE into 1 plus FE by D, and here it is FO by FE. You can see, my dear, thus the magnifying power at LDDB is greater than the magnifying power at infinity by factor 1 plus FE by D. इतने फैक्टर से 1 plus FE by D फैक्टर से the magnifying power at LDDB is greater than magnifying power at infinity, because by a factor of 1 plus FE by D, which is greater than 1. This factor is greater than 1, my dear. Because 1 is positive, focal length of convex lens is always positive and D is also positive. So my dear, this factor, by a factor, this answer is always greater than 1. This is 1 plus FE by D. 1 plus FE by D, so no doubt the answer of this will be always greater than 1, because it is more than 1, the answer of this. And hence, since the answer of this is more than 1, so of course, my dear, M LDDB will be greater than M infinity by a factor of 1 plus FE by D, which is greater than 1. इतने फैक्टर से, my dear, इतने फैक्टर से मैग्नीफाइंग पावर एट LDDB ज़्यादा है. आप देख सकते हो LDDB में FO by FE into 1 plus FE by D and infinity में खाली FO by FE है. तो इतने फैक्टर से LDDB ज़्यादा है, मैग्नीफाइंग पावर इतने फैक्टर से ज़्यादा है. और ये फैक्टर जो मैंने लिखा है that is greater than 1, because चौबे सर this is 1 plus FE by D. So of course this factor is more than 1, so M LDDB is more than M. This is one point. Second point is important to compare the length of tube. The length of tube in LDDB is, my dear, please take care, is FO plus UE. And third, the length of tube in infinity case, that is when image is obtained at infinity, my dear, is FO plus FE. So that's all, my dear. These are the three important conclusions which you are supposed to know, that Chobesar, like compound microscope, the magnifying power at least distance of distinct region, image formed at least distance of distinct region, is still greater than the magnifying power of the image formed at infinity. And by how much factor it is greater? It is greater by a factor of 1 plus FE by D, and 1 plus FE by D itself greater than 1. Second, the length of the tube in LDDB case, in earlier case, was FO plus UE. FO plus UE, but in infinity case, it is FO plus FE. So that's all from my side, my dear. This is all about your astronomical refracting telescope. Thank you all. Jai Hind you all. From tomorrow onward, I will start uploading the NCERT numerical so that you can easily attempt your test, which is beginning from 26th onward. Thank you all, and Jai Hind you all once again.